Hello everyone, I would like to show you how to do linear, quadratic, and cubic regressions, or models as they call them in Unit 4 in this video. So the first thing you need to do when you have a data set, you need to put them into Desmos and make a scatter plot. I have already one made over here, and over in the X column I clearly have years, and over here I have some kind of population. So when you look at this scatter plot, it looks more or less linear. Now, what do I mean more or less linear? Well, it doesn't look like a quadratic function, right? It doesn't have the little vertex, right? It doesn't have a vertex. It doesn't look cubic either, right? Because the cubic function generally looks like a camel, right? So your cubic functions on average look like this, or maybe they look like this, or maybe they look like this, but none of these is the situation that I'm seeing in the scatter plot. So I'm clearly working with something linear, and I need to figure out the model for this one. So what do I do? Well, if you all remember, the most common way we write down a linear function is, of course, mx plus b. So that is the type of command that I'm going to input into Desmos. But instead of mx plus y equals mx plus b, I'm going to reference my x and y coordinates of my table. So it's going to be y1 approximately equal to this little thing, mx1 plus b. And when I do it, it gives me this line. Now, you should be asking yourself, well, that's great, but how do I get the equation? Well, all the information is right here. Here is your m and here is your b. I can just plug them in. So y equals to 42.26x minus 83,635.2. It's right here. So it gives me both. It calculates the missing values for me. The next item that you would have to do, of course, is you would have to figure out, well, what is the value of this graph at some point further on? Well, I always feel that the easiest way to do this, for example, what is the value of this graph on 2011, right? What I like to do is I like to draw a vertical line at that point and then look for the intersection point, because this way it gives me the point. The x value is, of course, going to be your x value of the point, and of course the y value is what you're looking for. Super, super easy. So now that we have done our linear function, let's do a quadratic one. So here I have something that is clearly quadratic, as is evidenced by this lovely vertex that I have right up here, right? So clearly this is something quadratic. It looks like a hill or a bow, right? Remember, quadratics look like a hill or they look like a bow. Well, if this is quadratic, how do I put this in? Well, the general form of quadratic equation looks like this. ax squared minus plus bx plus c. And I can also input that into Desmos, only instead of x and y, I would have to reference x1 and y1. And of course, instead of the equal sign, because we're trying to find an approximate model, we pull that little tilde thing, like the curly thing. So this is exactly what I'm doing. y1, this little curly thing, ax1 squared plus bx1 plus c. And when it actually does, it gives me the values for A, B, and C. And you can also see that it clearly fits my quadratic scatter plot. So in order to write down this equation, I just need to take these A, B, and C. So y equals minus 4.9x squared plus 19.6x plus 58.8. Pretty simple. The last but not least, right, is the task where I have to find a certain, where I have to find a y value at a certain x value that I do not have. So let's say I want to find what is the value of this graph at point x equals 4.5. Usually I just draw a vertical line at that point and I look for the intersection point. So at point 4.5, my y value is 47.775. Super easy to find. So the next one up is, of course, the cubic regression. How do I do this, right? So over here, I've gone and put it into the scatter plot. And it looks like a snake, or maybe it looks like a camel. I usually say that they look like a camel. In other words, it has the looks that looks like this, or maybe it looks like this, right? Or maybe even like this, or like this. All of these are the shapes of a cubic graph. So I know this thing is cubic, so how do I write it down? Well, I do have a general form of a cubic function. And it looks like this. Y equals ax cubed plus bx squared. I think you can see where this is going, right? Plus cx plus d. And just like in all previous graphs, I'm going to type it into Desmos, but instead of x and y, I'm going to put y1 and x1, right? And instead of the equal sign, I will do this approximation sign. So y1 approximately equal to ax1 cubed plus bx1 squared plus cx1 plus d. And when it calculates it, you can see that this is a perfect fit. And I do get the values of all of these parameters so that I can write out my actual equation. So my equation is 0.015 x cubed minus 0.18 x squared plus 0.52x plus 5.72. I simply took all of these parameters and plugged them in. Very, very straightforward. And the last but not least, how do I find a value at a certain point? Let's say I want to find out what is the value of this graph at x equals 10. I draw a vertical line, and you can see, well, that vertical line is not on my screen. It's okay, you can pan it, and you can find it, and it's 7.92. Super easy. So a few more notes that I have to say on these models. All of these models are on my landing page in additional resources. So go find them. And you don't have to type these commands all the time. You can copy them, Control C, and you can paste them into Desmos, even into a separate file. Control D, just like that. Control V. So, once again, Control C, Control V, right? You can paste them from file to file. And that is all I wanted to show you today.